Alright everyone, we're going to continue from 5.2 and in numbers, starting with number 9. The problem says that we're going to test the claim about the population mean mu at the level of significance alpha. Assume the population is normally distributed. We have a claim that the mu is less than 5,015. The level of significance is 2/100 or 2%, and the sample statistic at 5,117. The sample standard deviation is at 5,725, and the sample size at 51. So, starting with finding our null and alternative hypothesis. So it asks what is the null and alternative. I noticed that in the claim that the symbol used here is the less than symbol, so mu is less than 5,015 will be our alternative because equality is not being used here. So the alternative hypothesis is that mu, or our mean, is less than 5,115. The complement to that being that the mean will be the opposite of that, which is greater than or equal to, notice the equality being here, of 5,115. Now let's go to calculate our standardized statistic T, our test statistic T. Remember from class, we're using the formula that T is equal to the sample mean minus the population mean divided by the sample standard deviation divided by the square root of the level of the sample size. Remember, for the purpose of your calculator, make sure you put in the numerator in parentheses and then your denominator in parentheses. So let's calculate. So 5,100. Let's do our parentheses. 5,117 minus 5,015. Close parenthesis, divided by 5,725 divided by the square root of 51. And we get this value. Notice we're rounding to two numbers after the decimal, so I'm going to record. Since 7 is greater than 5, that's going to bump this to the next value of 3. So I'm recording 0.13 or 0.13 as my T. 0.13. Okay? So now I'm going to use the calculator to find the p-value. So here, I'm going to my calculator, and I'm using stat. Tab over to calc, to test. Start over. Stat, tab over to test. We want option 2. Our mean is 5,015. The sample mean 5,117. The sample standard deviation of 5,725. The sample size is 51. And remember here, I need to choose based off of the alternative hypothesis. And since the alternative hypothesis is the less than symbol, I'm using the less than. Notice how it is now, this is the only one that is highlighted. That means it is actually being selected. So I'm going to tab here to calculate. And round it to 3 decimal places. Our p-value is 0.550. 0.550. Okay. Now, I need to now compare the p-value to alpha. I want to compare the p-value to alpha. So the p-value, so I want to compare p-value to alpha. The p-value is 0.550 and alpha is at 2% or 0.02. Well, this is about 55%. Well, this is 55% and this is 2%. So my p-value is greater than my alpha. So when the p-value is greater than alpha, then we fail to reject. Okay? Fail to reject the null. So let's make our interpretation. So decide whether to reject or fail to reject the null hypothesis. Choose the correct answer below. So here are options. Notice our paper has what the options are. In the platform, these will be drop down menus for your selection. So here we have an option to either reject or fail to reject. Well, we know that we are failing to reject. So fail to reject our null. Now let's talk about the reason why. If we fail to reject, that means that we are technically accepting the null. Then we are saying that we're saying that there's not enough oh, I guess we're saying is not. So sorry guys. We're saying there is not, that's your choices, is not enough evidence to either support or reject this claim. Well, here's where, so there is not enough evidence. So let's remember what we're trying to do. We are failing to reject the null, which means we are accepting the null and rejecting the alternative. So when I fail to reject the null, then I am accepting the alternative. I am accepting the alternative. No. We are failing to reject the null. That means I'm accepting the null. I am rejecting the alternative. There is not enough evidence at the 2% level of significance to support the claim. Remember guys, our claim actually lived in the alternative, but we really are rejecting the alternative because we're failing to reject the null. So we don't have enough evidence to support where the claim is. We are failing to reject the null. That means we want to keep that because there is not enough evidence at the 2% level of significance to support the claim, which happens to be where? In the alternative. And remember, I told you, when that claim is in the alternative, that word support is being used. So here we have another example of that. So fail to reject the null. There is not enough evidence at the 2% level of significance to support the claim. Okay, let's go to number 10. So here in number 10, we have, we're going to use our t-test about the claim, to test the claim about the population mean at the given level of significance and given sample statistic. Assume the population is normally distributed. Here we have a claim that mu is not equal to 24. Immediately, guys, that should tell you that that value or that claim lives in the alternative because it is not equal, okay, at the level of significance of 1% or 0.01. So I'm looking for my my null and alternative hypothesis. Well, I see that not equal to, which is going to be my alternative. So this could be my answer. I'm going to check the others. I know this is not the answer because equality doesn't live in the alternative. This is not the answer because that symbol is incorrect. And neither is this one. So answer choice A is the proper null and alternative. Okay? So where is the claim? I'm going to go ahead and write that in here. The claim is that mu is not equal to 24. I'm going to write that. The claim is in the alternative. Okay? Let's find T. I'm going to use the bottom. I can use the side here. So T is equal to the sample statistic, 22.5, minus the mean divided by the sample standard deviation of 4.6 divided by the square root of 13. When you do that math, you should get that T is equal to negative 1.18 approximately. Okay? So negative 1.18. Now our p-value, using the calculator, you can pause here to try to do that on your own using our keystrokes from the other problem, and you should get that p is equal to 0.263 approximately. Okay? Now let's think about how we're going to interpret our decision, or what we're going to decide, whether we're rejecting or we are accepting. Let's compare our p-value to the level of significance. We're going to compare p-value to alpha, 0.263 and 0.01. Well, 0.263 is greater than 0.01. So we are going to fail to reject the null. Okay? So that automatically knocks out that choice and that choice. Well, why are we failing to reject? Because that's what this is about. Well, we're failing to reject the null either because there's enough evidence to support the claim, or there's not enough evidence to support the claim. Well, we fail to reject the null. That means we are accepting the null. If I'm accepting the null, that means that there is not enough evidence to support the claim. So that puts us at answer choice D. So by failing to failing to reject the null, that means that we actually reject HA. If I reject HA, which happens to be the claim, that means that I do not have enough, so there's not enough evidence to support the claim, which puts me here. This is correct here, fail to reject the null, but this is incorrect here. There is enough evidence to support the claim. There isn't, because if there were, we would be rejecting the null. These are opposites of each other. I can't reject the null and then have enough evidence to support the claim, which happens to be in the alternative. I can reject the null. I can fail to reject it because I don't have enough evidence in the claim, which happens to be the alternative. Okay? All right. Next problem. Let's look at number 11. And for number 11, I'm going to use another sheet of paper because we have quite a few things that we have to do. Here we have some context. It says a used car dealer says that the mean price of a 3-year-old sports utility vehicle is $20,000. You suspect this claim is incorrect and find a random sample of 25 similar vehicles has a mean price of $20,635. A standard deviation of $1,983. Is there enough evidence to reject the claim at the level of significance equaling 0.10? Completes part A through E below and assume the population is normally distributed. So in this context, we have a claim. We have the claim that the mean price of a 3-year-old sports utility vehicle is $20,000. And then we have a sample, that's for the population. A sample size of 25 vehicles claims that there's a mean price of $20,635 for a sample. The standard deviation for the sample is $1,983, and then we have a level of significance. I'm going to write out what I know on another sheet of paper. Okay? So what I know is that the claim is that the mean is equal to $20,000 for the price of the vehicle. That's the claim. I know that there's a level of significance of 0.10. From here, I also know from the context that there is a sample mean of $20,635 and a sample standard deviation of $1,983. Okay? I can write my claim, my hypothesis, my null and alternative hypothesis based off of what I'm given. I see that in the context, the mean is equal to $20,000. That equality means that that is my H0. Also my claim. So the complement to that would be that the mean is not equal to 20,000. Okay? Alright. So that's the first part of our question. Part A. And so part A then would take us to answer choice F. Okay. Let's go to part B. Part B says find the critical values. So we got to go back to what we did in problems. I believe it was 2 or 3. Find the critical value and identify the regions. What are the critical values? Or T sub 0. So how do we find critical values? First, we find our degree of freedom, which is, let's go here, since our sample size based off the problem was 25. So the degree of freedom is 24. Alpha is 0.10. I also know that I'm finding the critical values. I need to know what type of test I will have, 1 tail or 2 tail. Well, in this problem, since it involves the not equal to sign, this will be a 2 tail test. So this is 2 tailed. Alright, so I go to my table and I'm looking for a degree of freedom of 24 at 2 tailed at a level of significance of 0.10. So the degree of freedom at 24 okay, let me see, put this down here. So 24, let me put that right here. There's 24. Here I need 2 tails, and the level of significance here is 0.10. So I move here, and I go up to that value, 1.711. I remembered that because it is 2 tailed, I have to use the plus and minus symbol. So my critical values are plus or minus 1.711. Okay? So go here, and the critical values are negative 1.711 and 1.711. Now we need to determine the rejection regions. Well, since this is a 2-tailed test, I know that my rejection regions are on 2 sides. So my answer should live here in A. And that's at T is less than negative 1.711 and T is greater than 1.711. Now I use my formula to find T, to find the standardized test statistic T. So let's do that. Part C. T is equal to the population, the sample mean minus the population mean divided by the standard deviation of the sample divided by the square root of the sample size. Pause the video here to calculate, find your calculation for T. Hopefully you obtain that T is approximately 1.60. 1.60. Okay. Alright, so now it's time for us, let's put that, T is 1.60. Now it's time for us to make a decision. Okay? So notice here we're not given a p-value, so we're not comparing the p-value to alpha. What we're given here is a critical region, and we're given our standardized, our test statistic. Okay? So we need to compare what we're given to T. So alright, so as we determine our decision, well, we compare the test statistic to the critical or rejection regions that we have. So 1.60, when I compare that or look for where that would be, remember in a two-tail test, remember the graphic that we created, this has a critical region negative 1.711 and 1.711. So we're testing whether or not those are the critical regions. If this number falls in these regions, where clearly 1.60 doesn't fall here, because 1.60 is about here, right? So it does not fall in the rejection region. It does not lie in that's the rejection region, that's the rejection region. So this doesn't lie in the rejection region. So our decision is going to be to fail to reject. Let's look at the reasons they have. Well, we're going to fail to reject for what reason? So we know that this is out and this is out. Well, here are our options. Because the test statistic is not in the rejection region, or because the test statistic is in the rejection region. And clearly our test statistic 1.60 is not in the rejection region. So we are failing to reject for this reason. And here's our evidence. It doesn't fall there. Not in rejection region. Okay? Now, part E is the interpretation of the decision from the context. So let's look at what that says. So, interpret the decision in the context of the original claim. Well, what is the original claim? What is that? The original claim is that the mean is $20,000 for a SUV, 3-year-old SUV. Notice it's mentioning this level of significance. Alpha is 10%. So we are failing to reject. Okay? So at the mean, at 10% level of significance, there's not enough evidence to reject the claim. Well, we know that we are failing. Let's look at where the claim is first. The claim is in the H naught. So when we say claim here, we're really talking about H naught, or the null. So we know that we are failing to reject. We just need to know why we are failing to reject. So at 10% level of significance, there is not sufficient evidence to reject the claim. Well, we are failing to reject the claim. So there's not sufficient evidence to reject that the mean price is not $20,000. Oh, that's where the issue is. This portion here is correct. There is not enough evidence to reject because we are failing to reject. Let me put that here. Fail to reject. This portion is correct at 10%. But is this correct? No, it is not. The mean price is not $20,000. That's not the claim. The claim is wrong. So this is out. Okay. Let's look at B. At 10% level of significance, there is not sufficient evidence to reject. So we don't have enough of evidence to say to reject it. That goes with what we're saying. We are failing to reject that the claim that the mean is $20,000. That's what the claim is. That so far is more true than this one. Let's look at C. At 10% level of significance, there is sufficient evidence to reject the claim. Well, this part is not true because we are failing to reject. So sufficient evidence to reject makes this false. At 10% level of significance, there is sufficient evidence to reject the claim that the mean is $20,000. Well, once again, we're not rejecting. We are failing to reject. So this part right here is incorrect. So let's look back at B. At 10% level of significance, that's here, there is not sufficient evidence to reject. This portion right here means we are failing to reject. Not sufficient evidence to reject means that I'm going to fail to reject. Or in other words, accept the claim. Well, what is the claim? That the mean price is $20,000. B is our answer. Okay. Let's go to number 12. Okay, similar problem. Here, a credit card company claims that the mean credit card debt for individuals is greater than $5,200. That's the claim. Greater than. You want to test this claim. You find a random sample of 36 card holders. There's our sample size. Has a mean credit score of credit balance of 5,329. There's our sample mean. And a standard deviation of 550. There's our sample standard deviation. At the 5% or 0.5 level of significance, can you support the claim? Complete parts A through E. Assume the population is normally distributed. So let's start off with the claim itself. What is the claim? The claim is that the mean is greater than $5,200, the credit card debt. That symbol means that this is going to be H alternative. So the opposite of this is the greater than, the less than or equal to, less than or equal. So I'm going to, in these choices, I'm going to look for this in my alternative. The mean is greater than 5,200. Here, no. Here, yes, no. Here, yes, so far. Here, no. Here, no. And here. Now I need to look at the opposite. What will be the opposite of that? Well, the mean, if that is HA, then the mean would have to be less than or equal to 5,200 to be H naught, or the null. So let's look at the two choices that I didn't eliminate. Here, they have the correct symbol here, but this one has an incorrect symbol. So my choice is answer choice C. Okay. Now the claim lives here in the alternative. This is the claim. I'm just going to have to keep that information in my back pocket for a moment. Alright, so let's find our critical values. That's what the first thing asks us to do. So go back. Remember, to find critical values, we need our degree of freedom, which in this case will be 35, because n minus 1 is 35. And then our level of significance, which is equal to 0.05. So let's find our degree, our critical value. Now, I see here 35. Let me do this. Here's 35. It's definitely a one-tailed test. I know that because it's not the equal and not equal signs are not being used. So the question becomes whether or not I use a plus sign or a negative sign. But let's find out. I know we're using a one tail. We want at the 0.05 level of significance. And so when I look at that, that lands me right here at 1.690. Now, do I use a positive or do I use a negative? And how would I know? Since my alternative uses the greater than symbol, then I know that I'm using a positive value. So this is a right tail test. So I use positive 1.690. Okay? So when I list it here, write it here mathematically or as an inequality statement, then I write it as T is greater than 1.690. That's a right tail test. Okay? Alright. So now we're going to find our test statistic using our formula. I want to allow you to pause the video here to calculate T using our formula. Sample mean. Remember, this is coming from the context. The sample mean is 5,329. We're subtracting that, subtracting 5,200 from it, which is our population mean, dividing that by the sample standard deviation, and dividing that by the sample size, the square root of the sample size, excuse me. Pause the video now to do your calculation. Alright? Hopefully you found that T is equal to approximately 1.41. So now we need to compare or test to see if this T value is in the critical or rejection region given by this value. Well, 1.41 is less than 1.690, so it will not lie in the rejection region. Will not lie in the rejection region. So since it won't lie in the rejection region, we're going to fail to reject. So let's update our paper. So our T is approximately 1.41. Our decision is to fail to reject because it does not lie in the rejection region. Then that puts us at answer choice A. Now we're going to interpret that in part E. So what do we know? We are failing, so we're failing to reject H naught, or the null. The level of significance is 5%, and the claim is that the mean is greater than 5,200, but the claim is also HA. Okay, so we're failing to reject H naught, or the null. Then that means we are rejecting HA. So if I fail to reject H null, then I am going to reject HA. Okay? So at 5% level of significance, there is not sufficient evidence to support the claim. What is the claim? HA. That the mean credit card debt is $5,200. Okay? At the level of significance, level of significance 5%, there's not sufficient evidence to support the claim. Okay? Well, we reject the claim because we are failing to reject H naught. So that means we are rejecting the claim, which happens to be the alternative. So far that may work. Let's read the others. At 5% level of significance, 5%, there is sufficient evidence to support the claim. Well, if there is sufficient evidence to support the claim, that means that we would be rejecting the null, but we're not rejecting the null. So this part of this answer is a violation. Let's look at C. At 5% level of significance, there is sufficient evidence to support the claim. That the mean credit card debt is greater than 5,200. Well, this part is correct about what the mean says. That is what the claim is. But if there was sufficient evidence to support it, we wouldn't be rejecting it. We would be rejecting H null. This part is incorrect. At 5% level of significance, there is not sufficient evidence to support the claim that the mean credit card debt is less than 5,200. Well, that's not even what the claim says. The claim doesn't even say that the credit card debt is less than 5,200. it says that it is greater than. So right here is the violation in that answer. Because this is correct. There is not sufficient evidence to support it, but not for this reason. So let's look back at what our answer is. At the 5% level of significance, there is not sufficient evidence. This part right here to support. There is not sufficient evidence. So that means we are rejecting the claim, which happens to be here, which happens to be HA. We are rejecting that because we are failing to reject the not or H null. Also, y'all, the mean, this has the correct claim in it. So that's also something to pay attention to. Okay. Alright, let's look at the next one. Alright. It says test the claim that the mean amount of carbon monoxide in the air in the U.S. cities is less than 2.32 parts per million. There's the claim. Let's write that out. There's the claim. Our claim is that the mean carbon monoxide is less than 2.32 parts per million. Okay? We know also that it was found that a mean amount of carbon monoxide in the air of a random sample in 62 cities, there's my sample size, is 2.38 parts per million. There's my X bar. 2.38 parts per million. And the standard deviation is 2.12 parts. So the sample standard deviation, 2.12 parts per million. At a level of significance of 0.05 or 5%. Okay, that's what we know from the problem. So I see that in the claim, the symbol less than is what I use mathematically. So that means that that automatically puts me at the alternative. So the alternative is that the mean is less than 2.32, which means that H null is the mean is greater than or equal to 2.32. I believe here, y'all, the options are going to be symbolic, so just remember that. So the claim is the blank hypothesis. It's where, y'all? The claim is here in the alternative, or HA. Okay. So we're going to first find our critical value. You can pause here to find your critical value. Remember, we find that by determining our degree of freedom, using the level of significance, and then going to the table. So you pause there. If we pause there, give you an opportunity to do that. So, you may find that, well, Ms. Thomas, 61, which would be our degree of freedom based off of this, is not on our table, right? So what I'm going to do is use the values between I'm going to use 60 as my degree of freedom. So as you can see here, 61 is not on my list, but I'm going to use 60 as my degree of freedom. I see 60. I know that this is a left tail test, so it's one-tailed, and I need to use a negative sign because the less than symbol is involved in the H alternative. So I go to 0.05 on and go up here, and I see this value 1.671. Now on the choices here, it asks for 2 decimal places. That's different. So 1.671 becomes negative 1.67. Remember, it's negative because this was a left tail test. I know that because it had the less than symbol in my alternative. Okay. Now it says, now visually, where would be the rejection region? Where would that live or land, or where would that show up? So let's look at those choices there. Okay. So remember, in a left tail test, the shaded region or that critical region is to the left of that T value, that critical region. So clearly this is two-tailed. This is one tail but right. We have a left tail, so this area right here is our critical region, and it's kind of light on your paper, but that's what's shaded. So A would be our answer here. Okay. Now let's find our test statistic, and we do that with our formula. Okay. T is equal to our sample mean, which is 2.38, minus the population mean, 2.32, divided by the sample standard deviation, divided by the square root of the sample size. Pause the video here to do your calculation, and you should have come up with approximately 0.22. Alright, so 0.22. Now we need to make a decision. Well, looking at the graphic, 0.22 actually would be somewhere about here, 0.22, which is not in the rejection region, because the rejection region is all here. So I'm going to make that note to myself. 0.22 does not lie in the rejection region. So since it doesn't, we're going to make a decision to do what, y'all? Fail to reject. Because the standardized test statistic 0.22 does not lie in the rejection region. So that's our decision. Now let's interpret it in the context of the claim. Well, what is the original claim? Let's bring that back to our minds. The original claim is that the mean is less than 2.32 parts million. I'm going to write that here. Here's our claim. But what else do we know about the claim? The claim is also in the alternative. That the mean is less than 2.32. Keep that in mind. And we are failing to reject the null, which I also got to get in my mind that I'm failing to reject the null. That means that I am rejecting HA. If I fail to reject the null, that means that I am rejecting HA. Because I failed to reject, that means I'm doing the opposite. Well, if I'm failing to reject the null, that means that there is not enough evidence at the 5% level of significance to, let's start here. Fail to reject the null. Look at what they're asking about. Let's read through. There blank enough evidence at the 5%. We already know what that is. That's from the level of significance. 5%. Oh, you don't have to put the symbol, y'all, because the symbol is there. Level of significance to blank the claim. So that means you're going to have some options here. This is, or this is not. This is reject or support. So let's see what fits. Let's go back to what are we deciding to do. We are rejecting the null, which means we are we are failing to reject the null, which means we are rejecting the alternative. If I am failing to reject the null, that means there is not enough evidence at 5% level of significance to do what to the claim. Because remember what the claim is, y'all. It's in the alternative, and that's your indicator that you're going to use the word support. We can't support this claim because the test statistic is not in the rejection region, so we are failing to reject the null. That means everything about the claim, which happens to be the alternative, is out. So there is not enough evidence at the 5% level of significance to support the claim that the mean amount of carbon monoxide in the air in the U.S. cities is less than, because now they want you to write what the claim is, less than 2.32 parts per million. Okay? All right. Next. Almost done, y'all. Number 14. And y'all, if you look on this page, you'll see your choices for those fill in the blanks. Remember, on your program, this will be a drop down, but here are your choices on those. Okay? All right. A consumer claims that the minimum time it takes for a sedan to travel a quarter mile is greater than 14.6 seconds. There's the claim. I'm going to write that. So my claim is that the mean time is greater than 14.6. You should be already making your determination. That's going to be your HA. So that means that the mean is less than or equal to 14.6 is your H null. Is your null or H nod. Alright, let's keep going. A random sample of 23 sedans has a minimum time to travel 1/4 mile of 15.5 seconds. Let's stop right there. There is my sample size. There is my sample mean. And a standard deviation of 2.08 seconds. And there's my sample standard deviation. At 10% level of significance, at alpha equals 0.10, is there enough evidence to support the consumer group's claim? So alpha is at 0.10. That's all the given information. So now we should be able to do this. So let's look at, if you look down at the bottom of your paper, you see your choices. So look at your choices. Number 1, your choice is sigma, sigma squared, p, or mu. Well, all of this involves the mean, so mu is our answer here for 1. For H naught, or the null, and we deduced that since the claim had the greater than, we need the opposite, which is less than or equal to. So you should be choosing less than or equal, which is here. Alright, let's update our paper here. So the mean, and look at the symbol, is less than or equal to 14.6. Notice there's no drop down for that one. You have to take that number from the context. Alright. Our alternative is that the mean is greater than 14.6. Where is the claim, everyone? The claim is in the alternative. And those were your options there. Okay, let's pick up that. Number 3 was mu, and this is greater than, and this is alternative. All right. Now let's find T, and then let's find P using our calculator. So let's pause the video here and find your T and P. When I come back, I'm going to be giving those values. Let's pause there. I'll give you a few moments to do that. Alright, everyone. You should have found your T, or your standardized test statistic, as 2.08. and the p-value at 0.025. Now we're going to make some decisions. Remember, when we have a p-value, we compare that to alpha. So compare p-value to alpha. Well, 0.025 and 0.10, clearly the p-value is less than alpha. Remember from previous problem, when the p-value is less than the level of significance, we will reject the null. Okay? So now we're at our decision making. Look down at the bottom of your page, you see your choices. So number 6 said we are going to either fail to reject or reject. Well, we are rejecting our null. We are rejecting the null. Okay. Now, because the p-value is let's look at the choices. Number 7 is not greater than alpha. That's our reasoning there. So we are rejecting because it is not greater. Okay? So now let's interpret the decision. Now when we interpret the decision, we got to bring back what our claim is. The claim is that the mean is greater than 14.6, which happens to be our alternative. So look at your choices. We're rejecting the null. There is or there is not enough evidence at the, what's our level of significance, 10%, to reject or support the claim. Well, we are rejecting the null and the claim is not in the null. Everybody with me? We're rejecting the null and the claim is not in the null. So that means that we have enough evidence. We have enough evidence. There is enough evidence at the 10% level of significance to support the claim. I know that I can support this claim because the claim is in the alternative and we're rejecting the null. So if I reject the null, that means I am failing to reject the alternative. I'm doing the opposite. If I fail to reject the alternative where the claim happens to be, that means I have what I need to support my claim. Okay? There is enough evidence at the 10% level of significance to support the claim that the mean minimum time it takes for a sedan to travel a quarter mile is, what does the claim say? That it is greater than 14.6. Okay. So to number 15, last one. Okay. An oceanographer claims that the mean dive duration of a North Atlantic right whale is 11 3/10 minutes. A random sample of 33 dive durations has a mean of 12 3/10 minutes and a standard deviation of 2 2/10 minutes. At alpha equals 0 and 0.10, there is enough evidence. Is there enough evidence to reject the oceanographer's claim? What do we know? I'm sorry, everyone, it's not been right there. What do we know? We know that there is a mean, that the claim is that the mean dive duration is which is equal 11 11.3, that's the claim. That's also going to be H naught because it has equality. Okay? So that means that the mean is not equal to 11.3 will be H alternative. We also know that there's a sample size of 33 dives, that the sample mean is 12 3/10 minutes. The sample standard deviation is 2.2 minutes. And this is all at a level, we're trying to find at a level of significance of 10% whether to reject this claim. Down at the bottom, everyone, you see what your options are. Here are your choices for those ones that have the numbers. So we're saying that the mean mu is equal to 11.3. The mean is equal to 11.3 as the null hypothesis. The alternative hypothesis will be the complement to that, that the mean is not equal to 11.3. Number 5 asks where the claim is. The claim is in the null. Let's find T and let's find P. You may pause the video at this time to find both T and P. I'm going to pause this wheel. Alright, y'all. So let's start off with finding T. So hopefully you found T to be 2.61 when you did your calculation. 2.61. But to find P this time, because we have a two-tailed test, two-tailed. How do I know I have a two-tailed test? Because I have the not equal to sign here. So the p-value when I find a two-tailed test is a little different. The p-value is equal to 2 times the area of the standardized test statistic. So let's write that here. P-value in a two-tailed test is equal to 2 times the area of the standardized test statistic. I spelled it wrong, y'all. Statistic. Alright, so what does that mean we have to do? We have to go and find from our table what that is. Okay? So let's go to the table. Alright, everyone. So at first I thought we were going to have to use this information about the p-value, but we actually don't. We can still use our technology. So scratch that. This also is true, but we don't have to use that here. We're going to use our technology like what we've done before. So we can use a calculator because we do have that option for a two-tailed test. We have that option of a two-tailed test in our calculator. So let's look at that. I don't think we had an opportunity to do one like that before. So let's do that together. So everybody hear me. For the record, we can use the calculator. Use calculator to find this p-value of a two-tailed test. So let's do that. I'll go to my calculator. Okay. And I'm going to stat, tab over to test. We want option 2. Enter. So here's my data. 11.3 for my mean, 12.3 for the sample mean, 2.2 for the sample standard deviation, and 33 for the sample size. Alright, now I tab down and look. Here is what's in my H alternative, the not equal sign. I need to choose that, and I want to calculate. I see the p-value. The p-value is 0.0136. If I round that to 3 numbers after the decimal, 0.014. That's what I'm going to record. 0.014 is my p-value. Okay, now I need to make my decision. I need to compare my p-value, compare p to alpha. So my p-value is 0.014. Alpha is 0.10. That is much smaller. So the p-value here, I'm sorry y'all, did I write that wrong? No, yeah, that's not what I should be getting. Let's go back. Okay, I'm sorry everyone, I got a little nervous, like that's not what I calculated, but that is correct. I apologize, and if I've confused you, I apologize. This is our proper p-value. Okay, this is the p-value. We are now going to compare that p-value to our level of significance. Because our level of significance, our p-value is less than our level of significance, we can make a decision. And remember, when the p-value is less than the level of significance, we are rejecting H naught. Okay? We're going to reject. We're going to reject our claim. So, reject our H naught. So here, and you can see down here at the bottom of your choices, our choice is here either to fail to reject or reject. So we are rejecting H naught because the p-value is not greater than alpha. Is not. It's less than alpha. Okay? Now we're going to interpret our claim, interpret our decision based off of the original claim. And I'm going to bring back what the original claim is. The original claim is that the mean is equal to 11.3, and that was our H naught. But remember, we just said we're rejecting the naught, H naught. Okay? So there is, let's see which choice we're going to make. So we got these options. There is or there is not enough evidence to support, enough evidence at the, what's our decimal, 10%, we go ahead and put that in there, 10%, level of significance, to support or reject the claim that the mean dive duration of the North Atlantic whale is equal to, remember what the claim says, equal to, we can go ahead and fill that in, equal to 11.3 minutes. So the question is, what goes here? We are rejecting the H-nod. If we're rejecting H-nod, that means that we have enough evidence, and we're rejecting the H-nod, and H-nod is the claim. That means we have enough evidence to reject. There is enough evidence at the 10% level of significance to reject. The only way we can reject it is that we have evidence to reject, and our evidence lives here because the p-value was less than alpha. So we can reject this because we have evidence to reject it. And then here, this is just listing what the claim is, that the mean is equal to 11.3 minutes. Alright, everyone. I apologize for that mishap up there. If you have questions about number 15, excuse me, if you have questions about number 15 or any questions at all, please don't hesitate to send me an email or reach out. This homework for 5, I will remember to assign the self-check of 5.2, the homework of 5.1, I believe, whichever I haven't done, that Ms. Boylan that you reminded me of. I'll remember to update that. This homework is due by the 28th, and then the window for the final will open on the 30th and will close whatever the last day of finals is. I believe it's the 5th, everybody. So if you have any questions, please don't hesitate to reach out. Thank you so much. Have a great summer.